And let us discuss about electric field intensity. Now, we already know what an electric field is. An electric field is a space around a charge where it can exert a force of attraction or repulsion on any other charge which is being placed there. For example, Qs is the source charge, and there will be a space around it where any other charge, if it just enters, either it will be feeling a force of attraction or repulsion depending upon its polarity. So that is what we mean by electric field. Now, how do we come to know about the electric field strength? For example, if I am keeping a charge from the source charge, and the source charge has already created an electric field around it, assume I am keeping a charge Q R distant away, capital R distant away, let it be R1, away from the source charge. So obviously, both being positive, he will be experiencing a repulsive force. Now the same charge is being kept somewhere near the source charge. Let the point, this distance be R2, let the same charge be kept here. So obviously we know that since it is closer to this, he will be experiencing a greater force of repulsion. So that quantity is defined by the term electric field intensity. So electric field intensity is denoted by the letter capital E, which is also a vector quantity, is the force experienced by a unit positive test charge being kept at a point in the electric field. Now force is a vector, so an electric field intensity is also a vector. Now the question is, so definition is like this: force experienced by a unit positive test charge kept in an electric field. So the force experienced by, why did they say the unit positive test charge? Because if you are taking a charge of a greater magnitude, that charge may repel the source charge and the net electric field will be disturbed. So that's why we are always choosing a magnitude value of unit positive test charge, and the equation will be something like this. As we all know, the force equation, Coulomb's law force equation, this is the source charge, this is my unit positive test charge being kept at a distance of r. So obviously they will be experiencing a force of repulsion. That force is given by F is equal to 1 by 4 pi epsilon 0 Q source by Q0 by r squared. Force experienced by the unit positive test charge means you have to divide by Q0, so 1 by 4 pi epsilon 0 Q source Q0 by r squared divided by Q0. You will get 1 by 4 pi epsilon 0 Qs by r squared. So this is the equation for electric field intensity. Now always remember the Q which is coming in that equation for the electric field intensity is the source charge which is created in the electric field, and it's not the charge which you are bringing in. So points to be remembered: point number 1, 1 by 4 pi epsilon 0 Q by r squared. If you write it in a vector form, you have to put one r cap here. So E vector equal to 1 by 4 pi epsilon 0 Q by r squared r cap. E is a vector quantity. E is inversely proportional to r squared, means as r increases, E decreases. Then the direction of electric field intensity is away from the positive charge, so positive to outwards. So direction of the electric field intensity is from positive to negative or positive to outwards.